Hi everyone, in this video I'm going to talk about the measurements of central tendency. So let me ask the question, if you are given a bunch of numbers or a set of data, how are you going to describe it? What is the best way to describe it? The most common answer is, let's take the average. So in this video, I'm going to tell you taking average is not the only option that you have to describe a set of data points. Okay, so measures of central tendency. Okay, so let's say average, right? Taking the average, not the only option here. Okay, right? It's not the only option that we have. The first thing that I'm gonna show you that you can use to describe your data is mole, right? So first, we're gonna talk about mole. So what is mole? Mole is when you have a set of data, the value that appears the most, right? So it's the values that appears the most. Okay, so that's how you find it, right? So if you have a set of data, you find the one or ones that appears the most. Okay, cool. And mole is the only measure of central tendency for nominal variables. So it's the only or option for nominal variables, right? Right, because for nominal variables, they're usually in categories, and you cannot rank them. The only option you can do is picking the one that appears the most. Okay, very good. And what's good about mole, right? Good, or what's good about this? It's very immune to outliers, right? So if you have outliers, mole is the best, right, to be against outliers. But what is not so good about mole? Not so good about mole is it's possible that in a data set that you have more than one mole, right? 2, 3, it's all possible. So bad or not good enough is can have more than one. More than one. And also, it's not very stable, right? Stability is something that we're going to talk next. So now, for now, I'm going to say it's not very stable. Not very stable. Okay? Yeah, mole is the first option that we have. Okay, next, we're going to talk about median. The second option we have is median. Okay, so what's median? So median, it's just the middle value of a set of data. Okay, so it's just says the middle value of the data set. Okay, cool. Median, you can only apply to data that are at least ordinal, right? Apply to data that are at least ordinal, right? Because you need to rank them or order them to find the middle one, right? So you have to be able to order them. Okay, so that's at least ordinal data. Cool. And what's good about this? Let me talk about good about this. It's very, well, not very, but let me say it's resistant to outliers. Okay. Okay. Well, so median is kind of in the middle. So next, I'm going to talk about mean, right? Mean is the average that we usually think about. Okay, so with mode, median, now we're going to talk about mean. Mean is our third option here. Mean. Okay, mean, basically you're gonna just add up all your values at. Yeah. So I'm gonna add up all variables and divide the number of, oh no, I meant add all the values, a number of values, right? So you add all the values and you divide by how many of them in your data set, right? Okay, cool. And this one is only applied to interval and ratio data, right? So you need the data, the values to be numbers to add them up to divide. Okay, cool. And what's good about mean, right? The good thing about mean is very stable. Okay, so mean is good about mean. It's the most stable, right? So it's the most stable of the three, right? It's the most stable of the three. And then the bad thing is about outliers can be a problem, right? So if you have one outlier that's really big or really small and you add the number into the total, you know, it's very easy to mess up with the value that you get for the mean. Okay, cool. So now we discussed the three options that we have for you to describe a set of data in terms of central tendency. So next, I want to talk about what does stable mean. So what stability of central tendency mean? So we're going to talk about stability of central tendency. Okay, cool. What, right? So stability of central tendency, what it means is that are you able to apply what you get or what you conclude from this sample and apply to a different set of sample, and the values are the same, right? So it means that values values for central tendencies not vary from one sample to another. One sample to another sample. Okay, right? So if you have a set of data, you know, it's one sample, the mode, the median, the mean of this set of sample or data, is it going to be different than a different set of sample? And that's stability, right? So if you want your the central tendency that you have to be stable, that means you don't want this value to be different across different samples. Okay, cool. So mode is not very stable. It's not stable because it's very likely that in one data set, the most often show up point will be different than a different sample set, right? And the median is kind of in the middle, where mean is the most stable one, right? In our statistic analysis, it's less likely for mean to be different across samples. So let me just put a rank. See them? Okay, cool. So order of central tendencies. So order of central tendencies, right? So we have mode with median with mean, right? So from mode to median, you're getting more stability. Okay, so the least stable is the mode. The most stable is the mean, right? That's how you rank them, right? So it's the most stable, and this one's the least stable. Okay, cool, very good. Next, I want to give you a few examples to demonstrate to you how you find mean, mode, and median. So let's do a few examples here. Okay, so mean, right? So we're gonna do an example to find the mean. Okay, so we have a set of data: 4, 9, 5, 9, 20, and 50. Okay, this is our data set here. So is it necessary to order them or rearrange them first before you do the calculation? And I would say if the question only asks you for the mean, it's not necessary. But most likely, if you're given a question, the question asks you for mean, the median, the mode, it should be a good idea to rearrange them first. Okay? So in this case, I'm only using this set of data to find the mean. Let's not rearrange them or reorder them first. Let's just jump into the calculation. Okay? So mean, the way you find your mean is equals to you add all the numbers, the values, and you divide by the total number. So 4 plus 9 plus 5 plus 9 plus 20 plus 50, you sum all the values, and how many data points are there? 1, 2, 3, 4, 5, 6. So there's 6 in total of them. And the values on the top, they add up to 97. You divide by 6, that's approximately 16.16, 6 to the bar here, right? So 6 continuous. Okay, and that's how you find mean. Okay, cool. Next, we want to find median. In median, I'm going to give you 2 examples. So example 1. Example 1, 7, 8, 15, 3, 4, 23, and 2. Okay. So for median, it's always a good idea that you just rearrange them first, reorder them first, from the smallest number to the largest number. So I'm going to rearrange. So we get 2, 3, 4, 7, 8, 15, and 23. Okay. So what you see from here, right? In here, the number of values in data set is odd number, right? So if 1, 2, 3, 4, 5, 6, 7, so total 7, which means that it's quite easy for you to pick out the middle number. Okay, just say odd number. Okay, so you count 3 and you count 3, and then your 7 right in the middle is your median. Okay, that's how you find median when you have odd number of data points. Okay, now we're going to do another example when there's even numbers in your data set. example 2, even number of data points in your data sets. And this one is, yeah, it's be the same, 7, 8, 15, 3, 4, 23, and 2, and then just add a 6 to it, right? So add a 6, now I have 2, 4, 6, 8 numbers of data points in your sample. So again, we're going to rearrange them. 2, 3, 4, 6, 7, 8, 15, and 23, right? So as you can see, let's count 3 from the left, 3 from the right. In the middle, there are 2 numbers, 6 and 7, they're in the middle. So which one should be your median, okay? So by convention, you're just gonna take the average of the 2. So your median is the average of the 2, 6 plus 7 divided by 2, and 13 divided by 2, that's 6.5, okay? So in this case, 6.5 is your median, okay? So this case here show you odd numbers of data points, and this one shows you even number of data points. Okay. Cool. Next, I want to show you 2 examples how you will find your mole. Mole. Example 1. Okay. 9, 6, 5, 4, 6, 15. Okay. Again, mole is the most is the value that appears the most, right? In this case, which one appears the most? 6 and 6. So the mole is 6. Okay. So I would suggest you, if there's enough time, that you rearrange your data set, right? That's then the mole will show up. It's easier to find for you to find the mole if you rearrange it, but it's okay that you don't rearrange it, right? Versus in the median, you kind of have to rearrange it for you to get the correct answer here. Okay. So there's only 1 mole in this example. Let me just add 1 more value to it. Example 2. 9, 6, 5, 4, 6, 15, and 9. In this case, there are 2 6 and 2 9s. Okay? 9, 6, 6, 9. What's special about this one versus in this case? This example shows you that there can be more than 1 mole in the data set. In this case, the moles are 6 and 9. Okay? Very good. Okay. So this concludes this video, and I will see you in the next video. Thank you for watching.